Take a look at traditional IT project management hubs, like the strict three-tier government frameworks used in Hong Kong. You'll find environments built on absolute control, rigid scope, and clear vendor oversight. In those traditional systems, software is deterministic. A project manager writes the rules, developers write the code to execute those rules, and the final application behaves exactly as instructed, every single time. But artificial intelligence breaks that model completely. Machine learning isn't deterministic, it is probabilistic. Instead of following a straight, solid line of hard-coded rules, an AI system generates outputs from a complex cloud of probabilities and learned inferences. Treating an AI deployment like a standard software update, where you launch it, check the final box on your timeline, and move on to the next task, creates a massive corporate liability. The machine is going to keep evolving. To survive this shift, project managers have to abandon the illusion of a finished project. Instead, they need to adopt a completely different lifecycle, a 7-stage system designed specifically as a web of constraints to trap and manage constant uncertainty. Stage 1, initiation and scoping, requires teams to define the AI system as a continuous, living product rather than a one-off IT fix. Before a single line of code is written, teams must assign one strictly accountable owner and lock in highly specific, smart success metrics to measure the model's behavior. That rigid planning leads into Stage 2, data preparation. 80% of project resources must be reserved for data work. Teams spend this time cleaning inputs, establishing data lineage, and scrubbing out biases to ensure compliance with laws like GDPR. An AI model cannot be stabilized or managed if the foundational data feeding it is compromised from the start. Once the data is locked down, Stage 3 tackles modeling and experimentation. This requires project managers to immediately drop the fixed-length, rigid development sprints used in traditional software. Because you are actively exploring unknowns, you have to use hypothesis-driven, variable-length iteration cycles. This includes scheduling short, highly intense spike time boxes designed to expose technical risks and dead ends as early as possible. During these cycles, success is never judged by one impressive output or a single test case. The model has to cross a rigid threshold of statistical significance over thousands of runs. In Stage 4, risk validation, projects are mapped against strict governance like the EU AI Act or NIST framework. Independent teams run audits using explainability tools like SHAP and LIME to unpack the algorithms and ensure the decision-making logic isn't a mystery. Stages 3 and 4 effectively tame the black box. They force the machine learning model to mathematically prove its logic and its safety before it's ever allowed to touch a production environment. When the model is finally approved for Stage 5, deployment, there is one overriding rule. You never launch an AI system to everyone at once. You start by establishing 3 tiers of baseline KPIs, spanning technical performance, business impact, and process efficiency. These serve as your absolute ground truth. Then you use isolated launch strategies, like a canary deployment. By routing 95% of your live traffic to the old reliable system and only 5% to the new AI, you severely limit the blast radius if the model starts generating errors. A prepared project manager always has a definitive, pre-approved rollback trigger ready for the precise moment the AI inevitably behaves unexpectedly in the wild. That caution is necessary because of a harsh post-launch reality. The exact moment an AI model goes live, its accuracy immediately begins to degrade. This decay is caused by data drift and concept drift. The model's training is frozen in time, but the real world it operates in constantly evolves and shifts underneath it. That brings us to Stage 6, monitoring and governance. Tracking this drift isn't an optional, nice-to-have feature. It has to be budgeted from day one as a permanent operational cost. You have to set hard statistical thresholds, using metrics like PSI, KS tests, or Jensen-Shannon divergence, that automatically sound the alarm when the model deviates too far from the baselines you established earlier. When those alarms go off, Stage 7 triggers. This is the iteration and feedback loop. Here, the team is forced to make a definitive choice based on the data, adjust the parameters, retrain the system, or retire the model entirely. Look at the backward arrow in the project flowchart. This creates an infinite loop. feeding real-world errors directly back into Stage 2 for fresh data preparation and remodeling. By abandoning the illusion of a finished project and embracing this continuous 7-stage cycle, organizations can take the volatile, unpredictable behavior of artificial intelligence and turn it into an observable, manageable, and highly successful business asset.